Now we're going to look at some facts about limits, which will be quite useful. Alright, so we're going to start out by assuming that f and g are two functions, so that the limit of f as x approaches c and the limit of g as x approaches c both exist and they are both finite. Further, let k be any real number. Then the limit of k as x approaches c is k. What does that mean? Well, let's take a look at an example. Let's say we have something like the limit as x approaches -1 of 8. So what this is asking is, what happens to 8 as x approaches -1? Well, the value of 8 does not depend on the value of x at all. The value of 8 is constant. It is 8, no matter what x does. So that's why we say that the limit of k as x tends to c is k. Now, these next facts, 2 through 5, are all fairly similar. What they tell you is that if you've got two or more, in fact any finite number of functions, added together or subtracted or multiplied or divided, and you need to find the limit as x tends to c of this result, what you can do is take the limit of this part and the limit of this part, and then combine the results that you get using addition in this case, subtraction in this case, multiplication and division. And the only instance in which you have to be the least bit concerned about this is when you're doing division and the limit of the denominator is 0. If the denominator tends to 0, then, well, this expression would not have any meaning. It would be undefined, and in that case this limit is not equal to that. So what you'd have to do in that case is apply one of the other methods that we've talked about or will talk about. So for instance, let's say you had the limit as x approaches 3 of 2 to the x times x squared. So property number 4 says that what we can do is take the limit as x approaches 3 of 2x, or 2 to the x, and multiply that by the limit as x tends to 3 of x squared. Or you could also do this mentally. You don't have to write out all the details. But as x tends to 3, 2 to the x is tending to 8. 2 to the third is 8. And then x squared is tending to 9. And so the answer is 72. So again, even if you don't write this step out, probably what you're doing is you are evaluating 2 to the x at 3 and x squared at 3, and then you're multiplying them together. Frankly, I can't think of an easier way to do that. But what you're doing is you're looking at these two parts separately and then combining the result. And that's fine. Alright, so that again applies to 2 through 5. And now let's look at number 6. Number 6 tells us that the limit as x tends to c of k times f of x is equal to k times the limit of f of x as x tends to c. So for instance, let's say we have this, the limit as x tends to, let's make it 5 of 9 x squared is equal to, now in this situation the role of k is being played by 9. If you've got a function that is multiplied by a constant, that constant factor can be pulled out front, and so what we would have is 9 times the limit as x tends to 5 of x squared, which would be 9 times 25 if I'm not mistaken, and let's see, what is it, maybe 225? Alright, so that's that.